Let us have another example. When calcium oxide and calcium dioxide react, they produce calcium carbonate. On the other hand, when calcium carbonate is heated in an open flask, it is decomposed to form calcium oxide and carbon dioxide CO2 as gas out of, and reaction goes to the completion. CaCO3 is a solid form, and this is decomposition reaction. When CaO and also solid form plus CO2 gas occur. Release. This decomposition reaction. Decomposition, we have take a flask and a calcium carbonate in solid. Heated it. It's decomposition of CaCO3 as solid plus CO2 as a reaction of the gas. Carbon dioxide release. Ca calcium carbonate as decomposition combination CaCO3 calcium carbonate plus CO2 gas release. Reversible reaction, establish equilibrium. CO2 forms and cannot escape CaO forms. Reversible reaction, showing establishment of reversible reaction in two reaction. Decomposition is reversible to decomposition. अगर हम इसके ऊपर एक कॉर्क लगा देंगे then और ये solid not hot, then it's come into it again its position, that is CaCO3. अभी हम इसे हीट किया, अगर हीट then it release carbon dioxide. When calcium carbonate is heated in closed flask or so that carbon dioxide can escape out as shown in figure. When carbon dioxide combining with CaO calcium oxide to form calcium carbonate, it's the beginning. Forward reaction is fast and reverse reaction is slow, but eventually the reverse reaction speeds up and both reactions go on at the same rate. At this stage, decomposition and combination take place at the same rate, but it opposite direction as a result amount of calcium carbonate and calcium oxide and carbon dioxide do not change. It is written as calcium carbonate 3 grams. Calcium carbonate in gas form, when it is heated, is change CaO into S plus CO2 and as a gas, carbon dioxide and calcium oxide. This is chemical equilibrium state of this reaction. B. Static equilibrium. Definition: when a reaction ceases by stop to produce, it is called static equilibrium. This happens mostly in physical phenomena. Example: a building remains standing rather than falling down because all the force acting on it are balanced. Dynamics equilibrium state. Definition: when a reaction does not stop, only the rate of forward and reverse reaction become equal to each other, but take place in opposite direction. This is called dynamics equilibrium rate. Rate of forward reaction is equal to rate of the reversible reactor. Dynamics means reaction is still continuing. Example: hydrogen dioxide, dye of hydrogen plus iodide is equilibrium form two hydrogen iodide gas में और iodide is also, अगर हम इसे हाइड्रोजन हमें we get obtained from boiling, when we boil the water we have get rest of hydrogen and plus iodine. Iodine is ऐड करें हाइड्रोजन में, अगर हम मैग्नीशियम ऑक्साइड को ऐड करते हैं तो ये आयोडाइड फॉर्म बन जाती है. आयोडाइड फॉर्म 3 हाइड्रोजन आइटम्स with 3H2G plus only 2 आइटम ऑफ द नाइट्रोजन गैस को ऐड किया जाए तो रिवर्सिबल रिएक्शन इज टू ammonia gas is released. Similarly, 2 hydrogen atoms are used in this reaction and plus 2 iodide gas. Iodine, for example, salt NaCl also find in a iodide form. आयोडीन इंक्लूड की जाती है. आयोडीन इज ओनली Mg. अगर हम सॉल्ट में Mg मैग्नीशियम को ऐड करेंगे और उसकी क्रंच लेंगे, फॉर एग्जांपल जैसे जेलाटिन पाउडर है, जैसे घरों में यूज़ होता है. सो ये आयोडीन हमें कैसे इस तरह से जेलाटिन पाउडर जिससे बनता है उससे आयोडीन निकलती है. 2 हाइड्रोजन आयोडाइड. अब हम यहाँ क्वेश्चन नंबर 8 करेंगे. ड्राइव द इक्विलिब्रियम कांस्टेंट एक्सप्रेशन फॉर द जर्नल रिएक्शन A and A plus B and B, रिवर्सिबल रिएक्शन और रिएक्शन विद रिवर्सिबल कहलाता है कि C प्लस C प्लस AD. यहाँ एटम्स इन्वॉल्व इन द एलिमेंट्स, जो एलिमेंट यूज़ हो रहा है और द रिएक्टेंट. Let us apply the law of mass action for a journal reaction. A plus B, AB, small b, B से KT and C is the reactant of the production plus D. This consists of 2 reaction, forward and reverse reaction. अकॉर्डिंग टू दिस लॉ, यही हमारे एलिमेंट अगर हीट कर किए जाएँ या कोल्ड किए जाएँ, अगेन वी हैव फॉर्म दिस 2 स्टेटमेंट. अ रेट ऑफ द केमिकल रिएक्शन इज डायरेक्टली प्रोपोर्शनल टू द product of the concentration of its reactants raised to power equal to the number of moles is in the balanced chemical equation of the reaction. According to the law of mass action, the rate of forward reaction RF is proportional to the element reactant A and B, where K and the power of A and the power of B are forward reaction is equal to Kf, constant of the reaction, and is equal to the reaction forward reaction constant and A B whole power A and whole power B, where Kf is rate constant for the forward reaction. Similarly, यहाँ हमारे इसी कांस्टेंट से जितने मोल होंगे यूज़ होंगे उतने ही मोल में कांस्टेंट भी इंक्रीज़ होगा. डायरेक्ट प्रोपोर्शन है. द रेट ऑफ द रिवर्स रिएक्शन reverse reaction is directly proportional to the product of C and power of C and D with power of D, where C and D are the number of moles as given in the imbalance equation. Thus, R rate of reaction, reverse reaction is proportional to the product 1 and the power of it, and D another product with its power, and Rf is equal to F constant of the forward, C and constant of product of C power and the product of D. The Kr is the rate constant for the reverse reaction. We know at equilibrium state the rate of both reactions are equal to each other. The rate of forward reaction is equal to the rate of reverse reaction, such as reverse rate of forward and equal to the rate of reaction is equal to the rate of reverse reaction. Now putting the value of R reverse forward reaction of the rate of forward and the rate of reaction, forward and reverse reaction. Kf, A, B are the component of the or element and their powers. P is equal to Kr and Kc and Cd is powers. Here is the example of the reversible reaction, and CaCO3 plus CaCO3 plus CO2 is also reversible. A or B is also equal to CaCO3, its power, and the CaCO3 plus CaCO2 is the 1 or 2 gives the reaction to H iodide, and 3H2 and 2 nitrogen items involved may produce product 2 of the ammonia, right? These are the A and B, and these are the A, C and D. Shows in the is a reversible and the reaction. The chart also. By taking constant, now यहाँ reverse reaction and the forward reaction, and A and B and the power of its. The elements involved of, for example, two atom are involved. So balance equation is 2. This is the power, right? This is the power of reactant CD, and this is the power of A and P. Power of A and element A and element B, and the power of element A and element of D, C and D. So we get by taking the constant over one side and the variables on the other side. So the equation, the above equation, turns into Kf constant of the forward upon the constant of the reaction is equal to C power C and D power D upon A power A and the B power B. Then the constant of equilibrium Kc is equal to K C power C and the D power D, A power A and the B power B, where Kc is equal to Kf upon Kr is called equilibrium constant. This expression is for chemical equilibrium constant. All the reversible reaction can be expressed in this form. If derive the equilibrium constant expression of the following reaction, if nitrogen gas with 2 elements, nitrogen gas with 2 atom involves plus 2 oxygen involves gas, oxygen gas give us a reaction is equal to 2 nitrate, 2 of the nitrate compound. Number 2, if 2 nitrogen item involves plus 3 of hydrogen item involves 3 into H2 3H2 gas hydrogen which react with nitrogen. Equilibrium is equal to 2 NH3 ammonia gas. Answer is N2G plus O2. Reversible reaction also heated 2GNO3 gas is creation. For the reaction, the rate of forward reaction F forward is equal to Kf and N2 and O2. The rate of reverse reaction R reverse is equal to Kr NO2 as well. The equilibrium constant expression for this reaction is Kc is equal to product upon the reactant. Kc is equal to NO2 and upon N2 upon O2. This is the AB and CD. प्रोडक्ट हमारी CD होती है एंड रिएक्टेंट जो हमारे रिएक्ट कर रहे होते हैं AB में प्रोड्यूस द Na2NO2 power. Only one involves or two. Only one item is involved. One item is involved. So is the power of power is 1 and 1. 3 power then square 2 of the nitrate. So is the answer.